Hello, everyone. Welcome. Welcome as well in the chat to the second to last workshops for the Chain Abstraction Hackathon. Today we will be hearing from Jovonni. I will invite him onto the stage now. He is a developer relations engineer from Agoric, and we will be going over Agoric's Orchestration API, as well as answer some questions later on.
Yes, thank you for having us. Pleasure to be here as always. Okay, hopefully some of you attended the last session that we did, maybe 30 minutes ago. Sorry, 30 days ago. This was on building cross-chain asynchronous smart contracts. So for some of you, some of this may be some recap, but we're not going to do the same workshop twice. In fact, we're not really considering this a workshop because we're in the middle of a hackathon. What we want to do is we want to pretty much empower all of those who are interested in building on Agoric. Let me share my screen here. So we're pretty much going to be hanging out for however long this is. Okay. So for the people who were here last time, this was the presentation that we did. Just as a small intro, my name is Jovonni. I'm a DevRel engineer here at Agoric, and I've been an engineer for about 15 years. I've been building in Web3 specifically since 2015 and never looked back. So pleasure to be here again. Okay, so just really quick, for those who don't know, what is Agoric? Oh, and for the record, hopefully you don't mind the volume of my voice. I'm a little under the weather from Token 2049 in Singapore. Great times, but I think I may have came back with something to the US. Okay, but so high level, what is Agoric? So Agoric is a layer one, and you can think of it as a smart contract platform. But in Agoric, you write smart contracts in JavaScript. Also, we have a security model that we call object capabilities. It's a I would say it's a very powerful concept, and it's a rabbit hole by itself. We have a bunch of papers on it, but I think you should, if you're interested in security, I think you should look into the differences of OCAPs versus other type of security models. We can talk about that a little bit. Also, we make use of something called hardened JavaScript here. And as of lately, we released what we call the Orchestration API, which is what we will be showing to you today, demoing, and actually instructing you on how to use during the hackathon. So we're not going to do a demo outright, so let's actually go through what we're going to be doing. So last time we showed you how to build on top of what we call this Orchestration Basics dApp. And what this is meant to be is it is a dApp that allows you to pretty much start building on using the Orchestration API pretty quickly. So last time we did a demo and we also walked through the code of this quite a bit. We'll do a little bit of that today. But I think one thing we want to do today is help you actually set this up and start building because, like I said, we are in a hackathon, right? And let's just go over the hackathon really quick. So here, I just want you guys to be reminded, this is real opportunity here. So first prize, we are offering a $5,000 bounty. Second prize is $2,500. And then for any teams in the audience that attempts to build a dApp and can make something meaningful, right? We are allowing you to share a prize pool of $2,000. So real opportunity here, designed to help you get your feet wet. Okay, so let's go here really quick. So let's talk about infrastructure, right? So if you think about it, with cross-chain dApps, if you want to have a testing environment, you're going to need a cross-chain testing environment. So one approach that you could take when doing this is you could actually try to mimic a cross-chain environment. That serves its purpose, but I think a more fun way of building cross-chain dApps is actually to have a real world multi-chain environment on your computer. The wonderful people on our team have developed this aspect of it. Let me back up a little bit. If you're interested, I would suggest go here and let me put this link in the chat. And also I'm gonna say one more thing. This isn't designed today to be me just talking to you guys. What I would love is for us to have a communicative experience today. So I'll be monitoring the chat. Actually, I'm gonna move this over here so I can keep it up at all times. Okay, so let's go back here. Okay, so setting up our cross-chain environment. Like I said, we want to set up a real cross-chain environment here with multiple chains and the infrastructure to allow these chains to talk to each other. So what we have here is something called multi-chain testing, and this is inside the Agoric SDK if you go to the link I sent you. And so this README here is going to walk you through how to install it, etc. But let's talk about what this is. So obviously you can have a blockchain node running on your computer, just running on your host. But a more isolated way of doing this is to have these nodes running inside of containers. And so what we have here is underneath, this is using Kubernetes. And for those of you who are not familiar with Kubernetes, just think of it as a higher level abstraction above containers. So in Kubernetes, you have this notion of pods, and you can think of a pod as a set of containers. And so what this allows us to do is this allows us to orchestrate, in another sense, orchestrate a set of containers that are the pieces of the infrastructure we want to set up. So what we're going to do here is when you set up this multi-chain testing, you actually set up what looks like this. So on the, actually make this a little bigger for you. Okay. So on the, close this. Okay. So on the right side here, what you have is here you have the set of pods that are running on my machine. And so this first pod here, this is the Agoric local node, right? So this is an actual Agoric node running in this container. This right here is a Cosmos Hub node called Gaia running in its own container. And then this one now here is an Osmosis node running in its own container. And if you see these three Hermes nodes here or pods here, these are all relayers running the Hermes Rust repo. Okay, so, but if you notice, look at the name of these relayers, right? So you have Hermes dash chain name. And what this is saying is this is a Hermes relayer that is sitting between Agoric and this Cosmos Hub node. Same thing for the next one, right? So we have Hermes connecting Agoric and Osmosis, and the same thing for the last one, right? So this is Hermes layer connecting Osmosis and Gaia. And the cool thing about this entire setup with Kubernetes is we can actually start looking at inside of the pods. Let's say, for example, and this is, remember, what we're trying to do is help you set up your entire infrastructure so that you can build throughout this hackathon and have a reliable infrastructure running. At any point in time, if you want to actually peer into the node itself, or into the pod itself, I should say, you can run, let me make this bigger. There you go. You can run kubectl logs, and then you can put the pod name here, right? And this -f is just going to follow the logs. And so if I run this, what I'm actually looking at now is I am looking at the node, the logs from the Agoric node running. And I can do the same thing for, let's say we want to do that for, let me rearrange this. Okay, no, that's fine. All right, let's say we want to do that same thing for Osmosis. I could take this pod name here, and I can just substitute this here. Okay, and boom. And now I'm looking at the logs from Osmosis, and I can do the same thing for Cosmos Hub. Now, why am I showing you this? Because when you are developing on Agoric and you deploy your contract, you will want to observe the logs that are running on the node, right? Because that's where your contract is deployed. So that's going to be useful for you. And you can also do the same thing for the relayers, right? And this is going to be important because at some point you're actually going to trigger trigger an IBC message, which is going to be handled by the relayer. And so at that point, if you ever need to debug something, you'll be able to just look at the logs itself from the relayer. So you can do the same thing, right? Let's kill that. Oops. There you go. Okay. So now this is the way that you can look into the Hermes logs. Okay. Boom. And now you can see we have our client is valid. And this is what you want to look for. You don't have to get too deep into what IBC is actually doing here, but you want to look for these client is valid. Another thing is, because you're running a real blockchain, several blockchains, and you're running real relayers, you have to worry about real relayer things, right? Or challenges. So one of the main things is as you're testing your application, you want to ensure that the IBC channel does not expire. And if it does, that means that when you try to send IBC messages across the relayer to or from chains, it won't actually make it, right? This would allow you to actually, do this. This would allow you to keep the channel alive, right? So I have a command in here that is pretty much just running client updates in a loop, pretty much infinite loop, just to keep the relayer alive, the channel open. Okay, so to recap this, you want to go to this multi-chain testing and you want to actually set this up first, in my opinion. Once you have this set up, then you'll have pretty much all of the infrastructure that you need. Okay, so now let's actually look at the actual dApp now. So here we have a dApp, and actually we'll look at one more thing. Let me actually go to this slide really quick. Okay. So in Agoric, we talked about this last, actually, I'll put the slides for you because these are the same slides that we went through last time. For those of you who were not here, let me check for any comments, questions. Okay. Any questions, just interrupt me, no problem. All right. In Agoric, when you want to, like for anybody who has developed Solidity or Cosmosm, you are familiar with the notion of writing state to the chain and contract state specifically. And so the way you do this in Agoric is we have this notion of vStorage. This is actually one of our Cosmos SDK. Here, I'll show you. So if you're interested, SDK, boom, we can go to Golang, we can go to X, and here you have this notion of vStorage, right? So here's a spec if you're really interested, but essentially what it is think of it as hierarchical storage. And so what you do is, this is a very key thing, right? So it's hierarchical storage, and so what you're doing is you're storing at specific storage paths. And this is the main part here. So when it comes to reading and writing, this is the way that vStorage works. So vStorage is write only for contracts and it's read only for clients. And so essentially you have to get into this workflow of whenever you want to write some data, you write it from your contract to vStorage with something like this, right? Where you are invoking this method, set value on a specific storage node. And then your client, what it's going to do is it's going to read from vStorage, right? It will show you how that's happening. Okay. So now this link right here, and I'll give this to you as well. This link right here, this is just a pretty useful web UI. We actually have an updated version. I should have put 2C's version in here, but there's a better version that just actually got released not too long ago. But what this is doing is it's just allowing you to read vStorage from whatever node RPC endpoint that you pointed to, right? So right now what this is pointing to is my local node on my machine. But as you see what I'm doing, I am searching for this notion of Orca, which is the name of our contract instance, right? You could also do this in another way. What you could do is you could do this from the CLI. You could do AGD, which is the Agoric daemon. You could do AGD query vstorage, and you could say children. Let's see, published Agoric names. Okay, and then you'll see here we have a few child nodes, I should say, that I'm reading from at this specific storage path. Remember, we said that it's hierarchical storage, right? So what we want to do, and just for the record, I have not deployed the contract yet. So I'm actually going to do that in front of you and pray to the demo deities. Okay, but if we do this and we look for an instance, let's do data. So you have two subcommands you can do. You can do children and data. Children is going to get the child nodes, and data is going to actually get the data at the storage node. Okay, and so here, this is a list of all of the instances that are on my local node, in my local Agoric network. But what I'm doing here is I'm searching for Orca, just to verify that Orca does not exist, aka that our contract has not been deployed. So let's walk through how you actually do that. So this is our repo. We went through it last time, but I'll go through a bunch of stuff here again. Let me close some things. Okay. So in this repo, you have a few folders that are of interest, right? You have this contract folder. Actually, this whole thing is a Yarn workspace, right? So it's one Yarn workspace, and it has two workspaces in it, like sub workspaces. You have contract and you have UI. So UI is obviously where this UI sits, but then you have this contract, which is where our contract is. So what we're going to do is we're going to navigate to contract. And what I'm going to do, we've created this convenience for you. If you want to just deploy your contract, what you can do is you can run this command right here. And what we did is we wrote a script that is going to deploy this contract for you. And I'm just parameterizing it with my contract specifically and the proposal for it. And what's going to happen underneath is the Agoric JavaScript VM is going to do a core eval on this proposal to actually deploy it. And first is going to install the bundle. Then it's going to, and there's a core eval for that. Then it's going to do another core eval to actually deploy it or create an instance. And what happens underneath is there is a governance proposal that is submitted to the chain. And then validators actually vote on this. And so for local purposes, what we have here is the voting threshold for the proposal is 0%. And then I think the time is just way shorter than what you would have in a normal world. What we're going to do is we're going to deploy this. And before I do this, let's go to remember what we want to do is we want to look at our logs on the chain, right? Okay. And before I do it, let's just deploy it first, and then we'll get to it. Okay, so I'm gonna run that. This is going to actually start doing some things that I could walk you through. Okay, so it's submitting the proposal, and then what the script is gonna do is it's going to wait for the proposal to pass. So you see it's waiting. Just give it a little bit, and what I'll do is I'll walk you through what parts of the contract you want to take interest in during your hackathon. Because the Agoric rabbit hole goes very deep. You can do a bunch of things in this space that you can get lost in a good way. Okay. All right. Boom. So now I'm looking at my chain logs, remember? So now I see these new types of logs, right? And so see, these are all logs that are actually written in my proposal and contract. Okay, so that deployed. So now, actually, let's do this. Let's see. Okay, so let's look at our viewer in the browser. So see, now we have a contract instance of Orca. And if I run that command that I had before, let's see here. Now you'll also see Orca under data under this hierarchical storage path of publish.agoric names.instance. So this means that I just deployed my contract. Okay, so now let's go back up to where our logs are. All right. So just to prove to you that these are logs from inside of my contract, let's just look for this number right here, just for debug purposes. So searching here, where is it? Not UI here. All right, that's in our proposal. Okay. So you see, when you see these logs in the chain, these are actually the logs from our proposal. Because remember what I mentioned, that the proposal goes to a court. Like there's a governance proposal that is put on chain, and then your proposal has a core eval is used in a core eval. And so to visualize this, there's a few slides here. So let's go here. So last time during our workshop, we talked about this notion of Zoe and how Zoe is this on-chain framework, right, that runs inside of its own isolated environment that allows you to do things in a more secure way, right? Because Zoe enforces this notion of something we call offer safety, where if you want to, so when you want to interact with the contract, you submit an offer to it. And in this offer, you have this proposal. And in this proposal, you can have this notion of what you want to give up in the offer and what you expect to get back. And Zoe is a framework that, among other things, allows you to be guaranteed that unless you get what you say you want in the offer, then the deal doesn't go through. Think of it that way. And you get a full refund is more concrete. In these Zoe concepts, you have this notion of offer I just spoke of, but you also have this notion of a proposal. So, let me see. So in the proposal, we talk about, this is what I just mentioned, that you have this notion of give, what you're actually giving up in the offer and what you want. And here you have this exit criteria, which is optional. You can set it if you'd like, but it's different criteria under which the deal would expire, or the offer would expire, or the proposal. Okay. So the key thing here, though, is, so this is different than an actual proposal from a governance perspective. This is why I brought this up, because from a governance perspective, this is like, if for those of you familiar with Cosmos SDK, if I did something like, let's say, AGD query governance proposals, right? Actually, let me do this on a bigger thing here. About to check for questions too, just in case you have any. So let's do that here. Okay, so this command right here, what this is going to do, this is actually invoking the gov module in Cosmos SDK. And how I'm doing that is if you just take that away, it says it right here. This is the help for that. But this proposal is different than a proposal with respect to submitting an offer to a contract. So I just wanted to point that out because just for clarity. Okay, if we go back to our logs, this proposal here is not a Zoe proposal. This proposal is the proposal that is submitted by governance, and our proposal that is in our, like, that was our proposal that we submit to the chain to create an instance of our smart contract. This proposal is where the logs is coming from. Okay. We might want to have a graphic for that in the future too, to make that a little more concrete. Let me see if anybody has any questions on that. Okay, cool. All right. So now that we have our proposal up, let's go back to our UI. So now what we can do is, I'll just refresh the UI just to be safe. Okay. So now what we'll do is let's actually go through this. So let's double check and make sure that our relay, okay, our relay is still running. Good on that. All right. So let me start running some logs again. Because remember, I said what you want to do is you want to run logs when you're deploying and testing out your contract too. So, okay. Now what we're going to do is we are actually, before I actually run it, let's look at the anatomy of the contract. So if you recall last time, the way we set this up is you have this notion of a contract and you have this notion of a flows file, but together these make up your smart contract. We're just separating these out for conveniences for the developer, right? But this contract, you can think of this as where you define these invitation makers. And these invitation makers, remember, if we go back to our slides, one of the concepts in Zoe is this notion of an invitation. And let's look at what an invitation, let's relook at what it's doing. So with an invitation, in order to interact with a contract, you use an invitation, and you can get an invitation by someone giving you one, or you can just invoke an invitation maker. Okay, so let's go here. Okay, so in our contract file, here's where we define our invitation makers. And so last time we walked through what this orchestrate all is doing, but you can think of these as handler functions for your invitation. So whenever someone submits a transaction to your contract, these handlers are what is going to handle that response. And here you see this use of ZCF, which is the Zoe contract facet we talked about last time. This is just supplying you with different resources to do Zoe specific things. But here what we're doing is we're defining one invitation maker here that is returning an invitation to be handled by this orchestration handler. And so let's look at what that looks like. Actually, I'm going to split this up on two screens. It's going to make it easier, I think. Okay, so on the right side here, we have this orca.flows file. On the left side here, we have this orca.contract. And so remember, this is our orchestration handler. So when you get into hackathon mode, what you want to do is, one thing is you're going to want to start making your own invitations, right? Let's say if you want to do like an airdrop or something like that, you might want to have an invitation here that is for claim or something like that. And depending on what your claim criteria would be in your airdrop. And so essentially, you want to get in the habit intuitively of when you make an invitation maker, you need to have this orchestration handler to handle it. And so if you look at this make account invitation on the left, this is the orchestration handler. On the right side, this is where we define this make account. So what we're doing here is we pass in this orchestrator, which is where you start to get exposure to using the orchestration API. And those of you that are interested, there's a link here. You can go to right here. I'll put this in the chat for you. This is a README file showing the different example contracts that we have in the Agoric SDK repo. And so if you look at here on the left side, you have the contract name. On the far right side, you have the features used, right? So you see things here for like interchain queries. You have this notion of V storage, right? So there's different features that these example contracts use, right? But if you look at the a common denominator here, you see this orch object that is being used, right? You also see orch account, which we'll show you in here in a minute, but you see this orch object being used repeatedly. And so this orch object, this is the orchestrator that we pass in here, right? So let's walk through this function really quick, or this method, this orchestration handler, I should say. So here, what we're doing is we're using this function of must match. What we're saying is that we want this offer arg here. We want this to have this chain name as actually, this shouldn't be here. Why is this there? Okay. We want this offer arg to have key for chain name, and the value associated with that key should be a string, right? So this is just think of it as a way of us checking against the parameters that we pass to our orchestration handler. And the offer args it is what it sounds like. It's the arguments of the offer, right? So when I'll walk you through that on the UI too, because after we walk through this function, I'm going to actually run it. So as we continue, we're here, we're just destructuring this chain name from this offer args. And here we're not moving any funds around, so we're actually exiting the seat here. And those of you that were here last time, this seat, actually, let's go to the slide here just as a reminder. So another aspect of Zoe is this notion of a seat. And a seat, so think of it as this, like Zoe has this notion of a seat, but there's two perspectives of the same seat. So one perspective on the bottom here is this user seat. So if you're a contract that submits an offer to another contract, that is going to return to you a user seat that you can then do things with, withdraw money or withdraw payments, etc. But inside the contract, you have this notion of a ZCF seat. And so that is what this is here. This is the ZCF seat. So we're not moving any funds around, so we're just going to exit that. Okay, so now you see the first use of using the orchestration API. So here, what we're going to do is we're going to invoke this method called getChain, and we're going to pass in a string variable, which could be something like osmosis. It could be Cosmos Hub, right? This could be whatever chain that is supported by the registry that is on the chain that you're using. And how do you check that? Okay, really quick. So for the devs who are building, remember we're in vStorage now. So what we're going to do is we're going to look at inside vStorage, inside Agoric names, remember hierarchical storage. We're going to look at two things. We're going to look at this chain storage node. And what's here is this is a list of the chains that are actually supported by this chain registry in the actual node. And then you have this notion of chain connection. So when you set up this multi-chain testing environment, what it's going to do is it's going to actually update this so that because the Agoric main node, like mainnet node, has different values here for chain connection, because the real Agoric node is not connecting to anything of Agoric local, like the chain IDs are not Agoric local, it's not Gaia local, it's not Osmosis local. But if you want to check to see what chains you can connect to from your orchestration contract, you can look inside this chain storage node, look at the data there or the children under that storage node, and then also look at the chain connection. So for our purpose, what we're going to take interest in is this Agoric local to Osmosis local chain connection. Okay. So there's a relationship between whatever the string variable is that you pass in getChain here and what's the chain inside the vStorage. Okay. So when we invoke this getChain on this orchestrator, what we're going to get back is this chain object, right? So we log this out, and I'm going to show you that in the log when we run this. And then after that, what we're going to do is we're going to use this chain object to then make an account. And so what is an account, right? For those of you who weren't here last time. Okay, let's go here. Okay, so let's look at these orchestration concepts, right? So we talked about this chain object, we talked about this orchestrator, but we didn't talk about these accounts. So in Agoric, we have this notion of an orchestration account. And an orchestration account has two flavors. One is a remote account, and one is a local account. And so if it's a remote account, this is an actual interchain account. And if it's a local account, it's just Agoric, right? Okay. And this is just a brief on what interchain accounts are, right? But think of them as an account that allows another chain to control it. Okay. So let's go back here. Okay, so here on line 36 on the right, this is where we're going to invoke the make account method on this chain object. And one thing I want to point out, and this is maybe a little nerdy, but keep in mind, last time we talked for an hour about writing asynchronous cross-chain messages, right? And so we're taking it for granted here, because you see this word await and this word async here, right? But just keep in mind that these are actual async operations that are happening. So when we invoke this chain.make account, what's going to happen is we're going to actually submit a cross-chain message to whatever the chain is that we define here by chain name. And we're going to tell it to go make an account, an ICA on the other chain. So what we're going to do, let's actually do it now. So we're going to do on the UI, we're just going to select osmosis here. And what we're going to do is we're going to click create. So what happens now is we have this approval message that pops up. And so you can always look at the data here if you want to look at the details. We've worked with Kepler closely to actually make this readable for devs or anyone using this. So if you're a dev, your customers or your users will actually be seeing this user-friendly display of what's actually happening in this transaction. So the first thing is our offer args. So look, you remember this word, this chain name word. Chain name we're passing in as osmosis, and the invitation. So remember we talked about invitation maker. Here we're going to invoke this make account invitation, right? And so let's see where that is. On the left side here, that's this right here. And so what we know here is it's going to return an invitation to this make account orchestration handler. Okay, so let's run this. Okay, and before I click it, let's clear this. We're going to watch the logs here. And then what we're also going to do is we're going to do this on another thing. I want to do kubectl logs. Let's get because I want to watch my Hermes relayer logs. Okay, all right. So we're going to click this button and we're going to watch our chain logs and our relayer logs. All right, let's do it. Boom, clicked. So see, now we have some interesting logs happening here. Okay, boom, okay, all asynchronous. Okay, and look, we have a bunch of stuff happening here, right? Okay, look, now you see some work being performed by our layer. Here we have open acknowledgement channel, open confirm channel. These are the steps of the IBC handshake. And then look, what happens on our UI pops up an osmosis address that we just created, which is interesting. So what happened is, let's actually go through logs. Where are you? Here. Okay. Wait, higher. All right. Right here. Okay. So look at this log right here. This is chain object. That is this line right here. So what we're seeing is our logs from our actual our orchestration handler. And look, how you can tell is you have this version 0136 that we put here. This could be anything we want in the world, right? It's just a log. Okay. So what happens here is, once again, we're using this orchestrator to get a chain object for this remote chain, osmosis in this case, and we're going to make a remote orchestration account. And that's where this make account comes in. Okay. And then we are returning this as a continuing offer, which allows you to do things later, right? So let's say if you wanted to stake with that account later or do something clever like a transfer, you can, from the UI, use this continuing offer pattern, which we have documented on our site too. And in the near future, we're going to have some of this continuing offer stuff inside the dApps, so you won't have to do too much work. Okay, so now what we want to do is let's do something a little more interesting. Because what we just did is we just created an orchestration account. And what's cool is this is just a regular account on a chain, right? So what I can do is I can actually just send it some funds, right? So if I do this, I'm just going to do an IBC transfer here of some funds. And how you can tell is look at the type URL, right? So it's ibc.applications.transfer.v1.message transfer. Just a regular IBC transfer. And what you see here is the source channel, source port is the transfer. Let's see. And here you see the receiver is the osmosis account and the sender is the Agoric account, right? So two different chains, obviously. Okay, so now let's just send that. what you're going to see is you're just going to see some IBC denom pop up here, right? Because all the UI is really doing is just keeping track of all of the balances of native denoms that it has. And in this case, it's a IBC denom. All right, let's do something a little more interesting. So what we'll do is let's look at this other function. So let's look here. All right. So actually, let's look on the left here. So on the left here, we have this other invitation maker that we made. And so what this is an invitation maker for this orchestration handler for make, create, and fund. And the same thing, last time we talked about this notion of interface guards, but an interface guard is just a way for you to ensure that when something is being invoked, that the input parameters are parsed and checked and the output is parsed and checked. Similar, just think of it in regular object-oriented programming, how you have an interface, right? An interface, you're really just defining some signatures that you want anything that implements the interface to implement. And so, same thing here. What we're saying is that when this invitation maker is called, we expect it to have no parameters and we expect it to return an invitation. All right. So on the right side, though, this is where the magic is. So once again, we have our orchestrator here. And what we're going to do now is we're going to use this orchestrator to do some more interesting stuff. But also keep in mind, we're actually passing in this method in our context that we're going to use as well. And another difference here is the chain name, the offer args have two parameters now. So we have chain name once again, and we have a denom. Okay, so here, if you think about our Zoe slides, we have this, we're actually getting the proposal now from the offer. And so because what we want to do is we want to use this give key from the proposal, which is pretty much we want to reference the funds that are being attached in the proposal. Okay, so if we come down here on line 69 and 70, if you notice, we are creating two chain objects now. One for Agoric and one for whatever the chain name is. We're going to pass in a osmosis here. Then we come down here, we're just getting the chain info for this specific chain, the remote chain. And this is going to tell us like what the staking denom is, etc. Now you'll see that in the logs. Then here we're just getting what assets are in the Agoric VBank so that we can use them or do whatever we want, check against them, etc. And so here you see we're calling make account twice. Make account one time on the Agoric chain to make a local chain account, and then we're calling make account again on the chain on the remote chain. But this is making two different orchestration accounts. This is key. Then here on 84 through 87, we're invoking this method for get address, which is just going to actually get us the address for both of these orchestration accounts we make. And then here's where we're doing some interesting stuff. So the first thing that we're doing, so think about it, we have this, and we probably want to make a graphic for this too in the future, but we have two orchestration accounts and then the user who's submitting the offer to the chain. So the user submits the offer and attaches funds to it. Then what the contract is going to do is the contract is going to deposit or give these assets to the Agoric orchestration account. And then the Agoric orchestration account is then going to do an IBC transfer to the remote orchestration account. Then what we're going to do, we're going to exit the seed after that. And then what we're going to do is we're going to then invoke this get balance method on the remote chain account, the remote orchestration account. And what this is going to do is this get balance is going to issue an interchain query to the osmosis chain to get a balance. And so once again, last time we talked about writing async cross-chain smart contracts. So once again, we're taking for granted all of these awaits in here, right? But key is this await right here is going to wait for this IBC message to be done. And then this here is going to wait for this interchain query to complete as well. But from a programmatic perspective, this is just all handled in line in your contract due to the powers of JavaScript. All right, so let's actually do this. Let me look for any questions. Okay, cool. All right, so let's actually run this. Let's clear this. Let's go back to our relay log. Let's clear that. All right, so let's do this. So let's do fun new. All right, so if we look at in our approval modal here, we are attaching 0.001 BLD to the offer. Then the offer args is we're passing in osmosis and UBLD as the denom. Then the invitation spec here is what I showed you before, this make, create, and fund invitation. All right, so we're gonna prove that. All right, let's watch some cool stuff happen. All right, logs, okay, we'll look at the logs later. Boom, so look, the 2 accounts just popped up, right? Okay, and look, one account just lost some funds and then went to the other account magically. Interesting. So let's look at how that actually happened. Well, we just walked you through how that happened, right? But let's look at these logs. I think you can trust me now that the logs are from the contract, but let's look at a few things. Remember when in our contract, we are logging a few things, right? So let's start here for this fetched assets. Just so we can walk you through that. Okay, fetched assets. This is from the VBank asset stuff. Okay, this is just showing all of the assets in our VBank. Then this local chain object here. This is just showing the methods you can invoke on that. Let's go down. All right, so here's one thing that's interesting. First thing is, look, ICA channel opened for this ICA controller 2. Okay, and this is the osmosis account that we made. Okay, but look at look here. In the code, we're actually fetching addresses, right? This is here, this get address. So here we're logging it out, right? These are the 2 addresses from the local chain account that we made, or orchestration account, and then the remote orchestration account that we made. Then let's go to, let's see. Let's look at remote chain balance, right? All right, so you see on this remote chain balance, we are fetching the balance of uosmo in the other chain, which is 0 at this point, but this is just showing that the ICQ works. And so here, if you look up here, let's see. All right, because remember, we cleared this before. So you see all of this work being performed, right? So you're looking at, again, open confirm channel, right? You're looking, you can actually go through these, but it's helpful to see what the Hermes relayers are actually doing. Let's see, ACK, search that. Okay, clearing package, you know that, okay. All right, here we go. Yeah, so see, look, send messages and wait commit, right? So this is how you actually make sure. So look, here you have the source chain, osmosis local, destination chain, agoric local. So this is the packet actually coming back from osmosis local, which is pretty cool. All right, so this is showing the make, create, and fund actually working. And once again, these are just accounts, you can fund them, do whatever. All right, so really quick, let me make sure we have any questions. No questions. Okay, you guys are quiet today, but it's okay. Hopefully you're learning. All right. So one thing I want to show you, since we're in hackathon mode, is the few ways that you can actually test your contract, right? So one thing you can do is, like I said, you can run this deploy script that I showed you earlier, but you can also do something like this. So we're here. Okay. You can also do something like yarn, Ava, test, Orca, multi-chain test. If you run this, what's going to happen is it's going to run, where is it? Test, multi-chain test here. Okay, boom, boom. All right, so what you can do is, so if you come from the Solidity world or the CosmWasm world, in Solidity, we use things like a Foundry. In CosmWasm world, we use things like TestTube. And what these allow you to do is spin up chains in memory and actually script the interaction with the contract as if it's on a live chain. But because this is JavaScript, you can also do real unit tests, right? But if you want to take it a step further beyond unit tests, you can actually run a real integration test with the chain, which will actually go through, deploy your contract, and actually pretend like it's a client and actually interact with the contract. So let me show you how to do both of those though. So what you can do if you want to run your test Orca contract, you can run this, and this will actually run your unit tests. But what's cool about this is if you come in here and let's say you want to, and this is something that you can't really do in a lot of other chains or contracts, you can actually put breakpoints inside your contract. So let's say if I wanted to run this right here, okay, I can just do this, run this, and you see my JavaScript debugger pops up. And now look, I have a breakpoint inside of my test. And so I can put these breakpoints inside my contracts and proposals, and I can actually step through my test, which is pretty cool. So that's one way you could debug your contract, and we can actually do a whole session on just that, which would be pretty cool. But if you wanted to run a full integration test against the chain, because that was just a unit test with like mocks and everything, what you could do is you can run this yarn ava test Orca's multi-chain, and the keyword here is this multi-chain inside this file name. This is going to run, so this is actually going to deploy my contract first. It's going to wait for the proposal to start to pass. And the cool thing about this is as I run my multi-chain test here, I could just watch my UI, and my UI will just start changing as if I'm clicking around it, which is pretty powerful because I'm watching. This is a way that I can actually test my client interactions with my contract in an automated way, which is really powerful. So boom, you have the proposal waiting to be passed, et cetera, et cetera. Let's see. And once that's passed, it's going to start actually submitting offers to the contract. So it should pass right here shortly. What did pass? Now it's just doing some other stuff. Boom. Okay, so now it's actually sending transactions to the chain for me. And watch, we're just going to watch this UI change a bit here. And thank you to the demo deities today for being gentle. But look, account just popped up. All right. Let's see. Should have some other ones pop up here. Let me see. Yep. Okay. Look, 2 of them popped up. Cosmos address popped up. One on Gaia. Look, Osmosis one just popped up, and I'm not clicking anything. That's because we script it. So it's a real integration test, similar to using Foundry or TestTube. We have a real chain running. This is just a chain running, not in memory. It's an actual node on our machine, right? And so look, money's being passed around between the orchestration accounts. Sorry, brain fart there. Let's see. Okay, see, and we have our test pass, right? So for the hackathoners there, you have 2 ways that you can really try to test your stuff. You can write just straight unit tests where you have a set of mocks, and this is a rudimentary set of mocks here, but we have better sets of mocks inside of our Agoric SDK. Or you can actually run your multi-chain testing stuff, which is a real test against a real chain. And so you have the options on how you want to test your stuff. I'll leave you with one more thing here. So as you build, what you really want to start paying attention to get started is use this dApp as a starting point. But what you want to do is, if you want to get something out the door quickly and start playing around with the API, just come in here in your orca.contract.js and start writing your own invitations here, your own custom invitations. It's like something like make airdrop invitation or something like that, or make cross-chain swap invitation or something, right? And then write a matching orchestration handler. And that inside the orchestration handler, this is where you can start doing all your magic stuff with the orchestrator object that we passed. And then you can quickly get a demo up and running fairly quickly by just using this as like a starting point, right? And in the subsequent talks, we'll maybe do some live stuff where we're creating something new, right? Okay, let me see if there's any. Let's see. A multi-chain test is good question, Maria. Multi-chain test is this right here, right? So this is using Starship underneath, which is just a wrapper around Kubernetes, which allows you to pretty much run a Kubernetes deployment of several Cosmos SDK based chains. And so what we do is we make use of that to spin up real multi-chain environments on one machine so that when we submit a transaction to our contract, it's actually sending real packets back and forth between the chains. And so that is when we looked at our logs. When we looked at our Hermes logs, that's essentially what we were looking at. We were looking at a relayer actually passing packets back and forth, which is pretty cool. Pretty powerful stuff. Okay, so any questions? I can talk about this stuff all day, right? What I tried to show you is how you want to get into the habit of testing your contract with unit tests and multi-chain tests, so like real tests. Then I talked about how you want to focus on making an invitation maker for whatever new functionality you want to put in the contract, and how you want to make a matching or an associated orchestration handler for that. I also talked about how you want to set up multi-chain testing, because that's going to be key. As I said in the beginning, set up multi-chain testing first, so that now you have a real environment that you can pass packets back and forth, right? And that's just, you don't have to do that, but I prefer doing that as a dev because I like watching packets go back and forth via a relayer between chains. Unit tests are good, but unit tests, when you're writing unit tests and you're just relying on unit tests to get things right, I think it's a recipe for things to be missed. And this is why when you're looking at like Solidity and Cosmwasm, we typically rely very seldomly on just unit tests. We actually spin up real chains in memory with Foundry and TestTube. So ideally, you want to get to this point quickly where you can spin up a real chains. And then I walked through in the UI. I have 2 minutes. Let me do something really quick. Okay, so in the dApp, what you want to do, and I probably should have spent a little more time on this, but I spent a lot of time on it last time. So if you're really interested, go back through the last talk that I did. So what you want to do inside the dApp is look at the orchestration inside the components orchestration. And there's an orchestration component that serves as like this top level component for all this orchestration work. This is going to show you how you actually submit an offer from the front end, right? There's this make offer function here, which is actually going to invoke this wallet.make offer from our, from our Agoric wallet connection here. This is where you're going to actually say which invitation maker you want to invoke, and then what the offer args are going to be. So if you look at the offer args, we're passing them in here. Let's see right here. So here I'm passing in the offer args, right? So yeah, definitely study this orchestration component that we made so you can see how you submit offers. And one last thing, let's see, where is this? Context, no hooks, no providers, contract. Okay, here, remember how I said before how we have vStorage and how you write to vStorage from the contract and you read from the client. Here's how you read from the client. So look inside this contract provider here, and you'll see these watchers. We are watching specific storage paths in vStorage, right? So down here, how the UI here is actually reading all of these orchestration accounts. What it's doing is all of these orchestration accounts are being written to this specific storage path in vStorage. It's publish.orca, and there's data sitting at that storage node. And so this is the thing that's actually reading it from there, right? So reading it is actually pretty straightforward from the client. We could spend some more time on that next time as well. And the last thing I will say too is I'm personally spending a lot of time in this Discord helping anybody who wants help to actually build applications here. So please, you cannot bug me. Feel free to talk my head off. I'm here for it. And hopefully this helps you get started onboarding to actually building on Agoric. I would say last thing, look at the talk that I did last time, which goes through this entire dApp infrastructure from end to end. And today was just a focus on setting it up and writing your own thing and how you're going to test it, etc. And hopefully these two talks together will give you a nice foundation so that you can actually go build some cool stuff and go chase this bounty money, if you will. Okay. Okay. You answered my question without a follow-up. Okay, awesome. Let me go through these. Does Starship work for big projects? Actually, what's interesting is we have some work being done with that team to do more stuff inside Starship that they're not doing yet. So think of it, underneath is just Kubernetes, right? So you can do anything you want. You just have to figure it out how to wire that up. So there's a few things that we're trying to push to get inside Starship, because I actually think it's a Swiss Army knife. It's actually one of my best friends, because if stuff goes wrong and my layer goes down, I could just run one command, wipe it all away, and just spin it back up, which is awesome. Okay, what is your workflow for unit tests? So the workflow essentially is, what you want to do is you want to run this command right here. I actually put this in the, so from inside the, let's see, from inside the contract folder, you want to run this is what's going to run that unit test, right? And then this would actually get you started and you'll see stuff actually happening. You can go through the unit tests as well. And if you have any issues with it, just ping me in the Discord. I'll be glad to help you on that. See if I can answer a few more here. Can you show the invitation maker code again? Yeah, of course, really quick. Sorry, I know we're going over time, but hey, people, we're in demand. Okay. So invitation maker, okay. That is going to be inside of your Orca contract. And so when we say invitation maker, think of it as this line right here. So we're using this Zoe contract facet to make the invitation, and then we're returning it. And then this invitation is what the client uses to actually submit an offer to the contract. And then this first parameter here is the offer handler or orchestration handler that the invitation maker is for. So that's the relationship there, but all in orca.contract.js. And I actually go into the invitation makers a little bit more in the last talk too. So if you want to check that out. Okay. Let me see. Hopefully not missing anything. Yes, yes. All right. Yeah, I'm here all day in the Discord. If anyone needs any help, you can find me on Twitter. You can find me on everything. So yeah, please, you cannot bug me enough. I see one thing coming in. Oh, of course. And honestly, I have to say, just personally, hey, thanks for attending and thanks for even asking questions. I'm glad that people were paying attention. And when people ask questions, it just gets me excited. And I know I'm not talking to a wall. So thank you. And then thank you for having us, Encode, of course, as always.
Thank you, Jovonni, for this lovely session. I'm sure there's more questions, but we can keep them for the Discord chat later on.
Yeah, of course.
And thank you everyone for attending as well. Tune back in tomorrow at the same time for the last session, last workshop for this Chain Abstraction Hackathon.
Yeah, of course.
And again, all recordings are uploaded on YouTube and available in your hacker packs.
Yeah, of course. Thanks for the questions, everyone, for sure. And if you rewatch them, please leave comments, likes. That'd be greatly appreciated. Thank you so much.
Great. Thank you. Bye,
All right,
everyone.
thanks, team. Take care. Bye.